Hello, ladies and gentlemen, and welcome to today's webinar. I'll start off by talking a little bit about Javelin. So the webinar is on imported geometry and working with that in general, and we're going to be using 2020. So a little bit about Javelin. We are a Canadian reseller of SOLIDWORKS, or VAR. We have up to 9 locations across Canada. What that means for you as a customer is, well, you get spoiled a little bit if you're on, say, tech support. I don't know what happened to BC there. But we have, I think, 13.5-hour support day. So pretty much any time of day if you're working and you need some help, support's there willing to help you. Just so you know who you're talking to, this is me. Bit of an outdated picture, but I'm a training and process consultant at Javelin. So what I do is I go into companies and I help them to optimize their CAD systems, SOLIDWORKS in particular. I'm also a senior instructor and subject matter expert. I have many certifications, one of them being my CSWE. I've worked in manufacturing since 2006. And I've been using SOLIDWORKS for a number of years now, since 2011, and working at Javelin since 2016. For those of you familiar with Southern Ontario, I'm graduated from Conestoga College in Kitchener-Waterloo area. That's where I currently reside. My past industry experience is quite well-rounded, I would say. Started off in lithography printing, went into automotive quality assurance, did a lot of manual and CNC machining, went into some additive work, did tool and die for the thermoforming industry as well as automotive. And of course, there's some mechanical design mixed in there. So just making sure everybody's in the right place. If you work with multiple CAD systems, so maybe you have multiple softwares that you use, or you work with suppliers or vendors that use other CAD packages. If you modify imported geometry, and when I say modified, I'm typically referring to either, I don't know, say taking an injection molded component and you're making the tooling or molds for that, or you're either referencing it. If you're doing any of that, well, you're probably in the right place. So when you're working with imported geometry, there's 3 things you'd like to see typically, at least I know I do. And that's being able to quickly repair my imported geometry. It does me no good if I could reproduce it in less time than it would be to import it. You need to be able to rely on these tools. So it needs to be safe, and you need to know things aren't being modified unexpectedly. And you also need to be able to use it reliably. That kind of goes hand in hand with the safely, but things like revisions and that sort of things will kind of speak to that. I've broken this webinar into 3 categories. And so the first section would be data translation. Anytime you get an imported model, whether it's from a customer or from one of your fellow designers, you typically need to translate that data into SOLIDWORKS. And that's a big component of just working with imported geometry in general. If things go awry in the data translation process, which oftentimes they do, we might need to do some manual repair on it. Typically at that point, we have our model and it's in a working state. We can reference it, whether it's direct or indirect, and then we go about our business. At the end of the day, maybe the 11th hour before you go home from work, well, you might get a revision. So we need to be able to incorporate that as well. So as I somewhat alluded to there, there's two main usage scenarios for your imported geometry. On the one hand, you have direct referencing. So something like a plastic injected part that I'm creating molds for. I would be directly referencing those surfaces and that body or component. And we'll talk a bit about this stuff. And the other scenario here is indirect referencing. So maybe you get a component from a supplier and you need to build your tooling or machinery, whatever it may be, around those components. And there's very different workflows involved with each. If you're looking at directly referencing your material or imported geometry, you need to make sure those surfaces are good. There can't be any, say, topological errors in them. So it lends itself to more of a repairing workflow in a lot of circumstances. The other one, you can see I have quite a large imported geometry assembly there at the bottom right-hand corner. And when you're getting these indirect references, you don't necessarily need perfect surfaces and have everything joined up. It's purely for reference. You're not, directly referencing it. So in a case like that, you're more geared towards, say, optimization of the imported geometry. Now, I'm touching on a few points from these two areas throughout this webinar, but if you want some additional knowledge in this, I would recommend Javelin's surfacing course for direct referencing, as well as the mold design course. If you're looking at indirect references or large imported bodies, things that take a long time to load, I would recommend our large assembly service and our large assembly and drawing workshop. The service is a little more hands-on. We go in depth and tailor and investigate with your needs in particular. And the assembly and drawing workshop is more of a public course, a little more general. So if what I'm going through today sparks your interest, please look into those courses. So as mentioned, section 1 is on data translation. So the big question here to start off with is, well, why do imports fail? And there's 3 main reasons why this happens. All our CAD geometry is mathematically computed. And well, essentially we can have rounding discrepancies in the, say, sender's computer. So say your supplier, maybe all their geometry is rounded to, say, I don't know, 6 decimal places for their models. And lo and behold, SOLIDWORKS rounds to maybe 8 decimal places. Well, that leaves a gap in the mathematical computation of our data. And if it's beyond what SOLIDWORKS can naturally stitch together, that creates some of these discrepancies, whether it's a hole or intersecting faces, things of that nature. We also have translation mapping. So when imported geometry is being brought from one software to another, not every software has identical features. One software may have a revolve command and one may not. And in that scenario, if the receiving system's CAD software doesn't have that specific feature, well, it doesn't know how to compute that. Essentially a little bit of reverse engineering. So that can also, again, lead to errors. And generally what it tries to do is then patch those up with several other things that it does know how to do. And the third and final point here is missing entities entirely. Some surfaces, whether it's, say, complex geometry, certain curvature, let's say, It just doesn't compute from one to the other. So it's similar to translation mapping. One's kind of feature-based, one's geometry-based. That's your three main concerns and why things fail on import. Unfortunately, you can't necessarily add features yourself to the software. I wish. And complex surfacing is complex surfacing. We can't really say dumb it down for the import process. So that those two are really we need to repair after the fact. The one thing we can control is the tolerance discrepancies. If you are finding that you have, wildly poor geometry that's getting imported, if you work closely with, say, your supplier that's translating out those files or exporting them, you can maybe tell them to go into their CAD package, whatever that may be, and to increase their curve tolerance. And that will give you a better import at the end of the day. So your three main data translation tools is first and foremost picking the appropriate file formats. We have import diagnostics to then kind of after it's been translated in to do some immediate repairs or automatic repairs. And then we have 3D Interconnect, which is kind of its own brand new, unique translation engine, we'll call it. Let's start off by looking at file formats. For those of you that are not aware, SOLIDWORKS is a parasolid-based modeling kernel, or uses that, I should say. So if you're working with a supplier and they have the ability within that software, whatever that may be, to export as a parasolid file, that's going to be your best option for importing into SOLIDWORKS. Because, well, it's a direct read. It's what SOLIDWORKS naturally uses in the background. Therefore, there's no quote unquote translation of data. So that's your best case scenario. Some softwares, however, maybe can't export in parasolid. And that's where STEP and ACES come in. STEP is a very good choice, and it's naturally designed as an independent kernel for CAD geometry and models. So by definition, it is kind of a universal file format. ACES is a specific kernel. It was designed in very similar in the way as a parasolid was, but it's not native to SOLIDWORKS. So whereas STEP is universal, ACES is kind of, lack of a better word, proprietary, but it does provide you with things like curves, surfaces, solid models, all that good stuff you're looking for in your imported geometry. And should all those fail or not be a possibility, you have IGES files. I would probably use this as a last resort out of these four. It's one of the oldest kernels. I think it originated in 1980 or something like that. And originally it was only designed to incorporate wireframe geometry. So, your topology is not there. It's more or less a 2D that was put into wireframe, and later solid bodies got incorporated into it. So it's more of an afterthought. And so there's my recommendations for your file formats. As far as the import diagnostic tool goes, if you've never used it, you absolutely should. It's you can put on settings to have this just kind of appear naturally as soon as you import a body. And what it does is it tries to repair it for you. Should there be any minor discrepancies in your geometry, this is going to help patch it up for you essentially automatically. So this is one of those fast automatic tools that you can use. Let me open up SOLIDWORKS here. I'm just going to bring in a step file. So you can see it translating all those surfaces. And right away, it comes up with a dialog box and it says, do you want to run it? And my recommendation is, again, to always say yes to this. Lo and behold, you can see I have some discrepancies here or faulty faces. So this tool is pretty good. All you really need to do is try and heal everything. You could kind of subdivide it out and say, just heal my faces or heal the gaps. In this case, I just have a few faulty faces. If we hover over top, we can get a little tooltip and it'll show me what kind of issue it's having. So this is, well, in this case, not very descriptive, general geometry problem. Whereas this self-intersecting face is a little more descriptive. We can always right click here as well, and we can repair these faces individually. We can see what's wrong. And we can recheck and zoom in to maybe investigate this visually. In general, though, what I do is just attempt to heal all. So you can see it's repaired a few of those faces, repaired two faulty faces, but it's left a third in this case. At this point, you might want to try it sequentially. So I might try to attempt to heal again. Sometimes by fixing a few faces, that lends itself to then fixing them again in kind of a secondary step. But I can press this a few times and it's not going to heal that faulty face. In this particular case, it's gonna, well, I'm gonna have to come in and repair it manually. It's worth noting, if you see any faulty faces or gaps in your geometry, you can see that that face looks fine. I don't really visually see anything wrong with this. If you try and reference it and offset it, things like that, you may wind up running into problems. And that's essentially why I recommend you run that import diagnostic tool every time you get an imported model. There's another option out there that I briefly mentioned, and that's called 3D Interconnect. So that is a new translation engine that's been put into SOLIDWORKS here. And essentially what that does is it, well, avoids the translation process. So I'm no longer translating data from one software to another and maybe interpolating things. I am just reading it from those original files. So in the bottom right there, you can see I've added a little chart as to what file formats are supported by 3D Interconnect. And it's a lot of the major CAD packages out there, aside from SOLIDWORKS. You can also do neutral files, a few that aren't mentioned here. So step files can be read in by 3D Interconnect as well. And so I'll go back to SOLIDWORKS here. And I need to turn on this 3D Interconnect if I want to use it. So I'll go to my settings and I'm going to go to my import options. And you can see there's a option or radio button here to toggle this on. Once that's toggled on, if I go ahead and open my step file again, you can see it's reading, not translating. And you'll notice when I go into my import diagnostics, I get, well, different faulty faces. I actually get a lot more here. I also am not able to heal those. So that's a little bit of a downfall, but because it's directly read from that native file, well, you can see why I wouldn't be able to kind of magically heal it for me. You'll notice the icon is different and it's also linked to the original. So I've shown you two translation engines in order to import your models. You may be considering or asking yourself which is better. And really the answer is not what in particular? You can see here that some are faster loading your model, or translating your models, I should say, using the 3D Connect, and some are actually faster with the traditional engine. So at the end of the day, what I would recommend is try both. Some might be better in some scenarios than others. 3D Interconnect might give you a faster import speed, but you might get more topological errors, and it might be the exact opposite depending on your models. So I would encourage you to try both, and it's just a matter of going into your options there and making sure this radio button is either on or off. And that'll dictate what engine you're using. Now that we're a little bit more familiar with how to get our models into SOLIDWORKS, we need to look at manually repairing them. So I see this as a 3-step process, or potentially 3 steps. The first one is to check your model to see if it has any issues. If it has issues, we need to patch those if we can. And if we can't patch it, we'll need to reproduce or replicate those surfaces. So we have 2 checking tools. I've shown you the first one, import diagnostics. The second one is check entity. I'll just turn that off. We'll bring in that same step file. And without using import diagnostics, I can go under my evaluate tab and check. And I can check this for invalid faces and edges. Lo and behold, it'll give me essentially the same results as import diagnostics. I can see I have a few self-intersecting faces and a general topological error. It will point those out as well. So you can see as I highlight it, it will point towards that area. So once we've confirmed there's problems, well, we need to go ahead and fix it. So I've differentiated a number of tools here into kind of 2 categories: patching and, what I'll get to in a minute, replication. As far as patching goes, you can see the list is a lot more limited in terms of tools we can use. And what it's doing is it's bringing forward that underlying geometry. I'm not telling it to reproduce anything, to guess anywhere. So this is where the reliability comes into play. Let's maybe show you a couple here. So I'm going to bring in a Parasolid file. I'm just using the traditional engine right now. Okay, we'll run our import diagnostics. And lo and behold, this time we seem to have got a gap. Again, that could be for difference in features through software. I'm not very sure at this point, but I'll get it to try and heal it for me. And so it looks like it healed that gap, but left a faulty face. And you'll notice it highlights it. We're going to heal it. And in this case, we're good. Now, if I'm directly referencing this, so maybe I'm making I'll use the example of a mold again. So let me make a plane. We'll just start a sketch on here. And maybe I'm referencing this face directly. So I would naturally come in, select all my geometry. Make sure we get all those little pesky slivers. and maybe convert it. Well, it works. I got my outline here, but you can see my geometry is all disconnected. This is not great to work with. Matter of fact, if I now took that sketch and I said reference up to surface or up to body, and then I isolate it, you can see I'm reproducing these, well, not so great surfaces. So in a scenario like this, I would ideally like to clean these up before I start directly referencing my model or imported geometry. One way to do that is simply to delete those faces. So I can come in here, pick my faces, and well, I'm not going to just delete, but I'm going to delete and get SOLIDWORKS to automatically patch it for me to its surrounding geometry. Now you can see I have a nice clean face. I have nice continuous edges. This is going to be a lot cleaner to work with and to directly reference. Bring up another example here. In this case, it's an imported surface body. If I try and do my import diagnostics, it recognizes some gaps here. If I attempt to heal, well, you can see it doesn't do a very good job, does it? I don't even know what it's going after there. So let's maybe not do that this time. We'll bring this in again. And if I need to patch up a hole in the center, this is a pretty wavy surface. So if I was to try and replicate it through a number of different tools, I could end up having different geometry. A few tools that would work well in this scenario are something like untrim. What it does is brings back that underlying geometry. So it's imported. I don't have a feature tree to work with, but you can see it just naturally kind of remembers those surfaces. And we're back to a fully restored complex surface. Another option would be to extend. So if I tell it to extend that edge using the same surface, it's again bringing up that underlying geometry, and I get a nice complete surface. I don't have to worry about any geometry discrepancies there. There is also one called delete hole. This is a really nice one to use. If I just select that, there's no options. I can't go wrong with it. Hit OK. And again, we're back to a full surface. So those are some of the patching tools that I recommend using. Now, as for replication or reproduction, so when my patching tools don't work, well, sometimes I have to recreate it. There's always a slight danger there. Now, some of these are reproducing the surfaces and some are replicating. So when I say reproducing, I'm referring to something like this, where it's taking a solid and it's contouring to that surface, reproducing the given surface. The replication side of it is something more like a fill, where it's taking the surrounding geometry and it's trying to then fill it. So let's show you a few of those. One of the easiest tools for reproducing surfaces is just to extrude up to. I use this a lot when I was making mold tools. So I can do a sketch on a kind of arbitrary plane. I can convert that geometry over, and it's just as simple as saying, well, extrude up to this body. And now that's a direct reference and it's being reproduced, but in this case as a solid. And then I have things like maybe fill surface, which is attempting to replicate. So I can select my edge there to fill that hole. Now I obviously want this to be smooth continuity between. So I'll put in my C2 curvature condition. Apply to all, fix, merge. And you can see it's pretty close, but how much can I trust that? Well, you can see here I did a bit of a comparison with, first of all, a patch tool, and then the second instance with that fill, exactly like I showed you. You can see a slight difference in the curvature in each one. So ideally, patching geometry is always going to give you your original surfaces back. Now, some other things to consider here is the performance. Some features are a lot heavier on performance than others. Let me just open a few models here. So this is just reproducing the surface in a number of different ways. I already showed you the boss extrude up to body. I have something like replace face, where I extrude through that surface. And then I just tell it to essentially take that top face of the block and replace it with my contoured or reference surface. And the third example here is, again, I'm just doing a blind extrusion and then cutting it with the surface. It's a nice, easy command to use. You just select your reference surface and say, cut everything in the direction of the arrow. All three do the exact same thing, but your performance will vary. So under my performance evaluation, now this is a simplistic example, so the time won't vary too much, but it is exponential as the complexity grows. Section 3 is on revisioning. So oftentimes, you're ready to go home on a Friday, and somebody sends you a revision, and oh, it's just a few fillets here or there. Can you incorporate it into your design? Should only take you 5 minutes, right? Well, not always. So there's 3 steps I see in the revision process. The first one is to compare. I need to see those differences in the revisions. Once I've validated that maybe they didn't send me the original model again, I do indeed have a new revision, then I can go into either one of 2 things. So either reloading or using the 3D Interconnect tool. And we'll show you the pros and cons with each. As for comparing, I like the Compare Documents tool. It's an excellent tool. So what I'm going to do is just close these down. I have 2 models here. It's that first kind of horseshoe looking model that I showed you. And one I imported with the traditional engine, one I imported with 3D Interconnect. So maybe I'm comparing the differences. Maybe this is a revision between models. Either way, this works well. I will say, however, in this one, it's the 3D Interconnect model. So I imported it using that 3D Interconnect tool, and then I just dissolved the feature. So if you just right click on that 3D Interconnect feature, you can say dissolve, and you'll be essentially left with this imported body like the traditional engine. You can see because it's, well, essentially two different engines. If I'm looking close in this corner, I have, well, fairly nice fillets here. And the exact same model translated through a different engine. You can see I have, well, not so nice. So this is why, again, I recommend trying out both and comparing. So let's go ahead and do that. Under the evaluate, we have compare documents. There's a few different things we could compare. So I'll compare the translated step file to the 3D interconnect model. And what we're going to look at is document properties as well as our geometry. And I can go ahead and run this comparison. So it does a nice split screen for me. And right now we're looking at the document properties. So if I was to compare revisions or maybe iterations through translation engines, I can see here that, well, it might be a small discrepancy, but I have a discrepancy in my mass. That should ultimately allude to some kind of change between the two. There's, of course, a number of other properties you could probably look at, but the one I really like here is to compare my geometry. I'm a more visual person. So let's go into our faces, and I'll show the unique faces. Highlights it on both. Notice how it spins it around on both. And again, I can focus in on that spot, and it's pointing out that, yeah, well, because of the different translations, I'm indeed getting different geometry there. But it works just as well for, say, revisions. You can also then, of course, save this out after as a report. Reloading. So I have a imported body here that you can see, and that's, well, my camera case. I'm, again, maybe creating a set of molds, and so I go ahead and I do my job. I throw in some mold tools there. I easily reproduce my core and cavity, and then again, 11th hour comes around, and oh, well, I forgot some fillets on the model here. Can you just make a quick modification for me? Well, sometimes it is just that easy. So let's go ahead and open up that model. So you can see I've quickly reproduced my geometry and made my cavity and core. And now I get a revision. So you can see my original import there, model 6. That's my camera case. And then Mr. Customer gives me revision A. Well, I want to go home. So maybe I'll just try to do a quick reload here. And to do that, I'm just going to go to that base feature, the import feature, and edit it. It's naturally going to pop up the open window, and it's going to say, well, show me my model. I can specify my file extensions here, find revision A. Now, before I hit OK or open, this is a very important radio button. In SOLIDWORKS, everything is mathematically computed and everything has an internal ID. So if I had a sketch with a line in it, it would be line 1 at sketch 1 at feature 1 at part 1 is essentially the internal ID that it goes by. And if I don't hit this check mark, all of those faces and internal IDs, entities, sketches, everything gets swapped out for something new. So now face 1 is face 2. And that's going to cause all my features to break. And now I have to reproduce my entire corn cavity. So let's check that box. Open it up. It's going to recompute that model. And you'll see now I have my new model with the fillets. Everything has been maintained in terms of references. I get those on both my core and cavity. And all is well. I can go home now. So just make sure you hit that little radio button. As for 3D Interconnect, it's not as straightforward, unfortunately. So let's take our .3D Interconnect model. So this might be, I don't know, say a CATIA file that I've used 3D Interconnect to translate in. This is the dissolve feature that I was talking about before. If you want to bring it back to just kind of a dumb import. So I read my, say, CATIA file directly into SOLIDWORKS, and then I referenced it and created what I needed to create. I have my tooling right here, actually. And we'll just show that. There we go. So all's well. And then again, Mr. Customer rings me up on a Friday. Well, I need you to replace this. I need to fill it on there. So, okay, let's try the same thing. Let's say edit feature. You can see it's a little bit different here, but essentially I still need to go browse and find my replacement model. So, okay, we're gonna bring it in. And lo and behold, it worked. That's strange. No, I did not replace that properly. Let's try it again. And that's going to be difficult. Revision A. More options will just bring to your system options here for importing. It's worth looking through this stuff. You know what? It's probably because I don't have 3D Interconnect on. Let's turn that on. There we go. So it's reading in my new model, and we see that all our features broke. So not only does it break my features that are directly referencing it, but if I had, say, components mated to this in an assembly, it's going to break those as well. So that doesn't become very feasible, does it? With 3D Interconnect, really your best option, because it's directly read, is to, well, unfortunately edit it in that native software. So if that camera case was a CATIA file, I would open up CATIA, modify that part just like any other part, save it, close it back down, open up SOLIDWORKS, and those changes will propagate and you should maintain those references. So you can't directly swap out your models, but you can update your originals. So again, I have only had an hour here to talk about the wonderful world of imported geometry with you folks. But if you'd like to learn more, again, if you're directly referencing, I would recommend your surface modeling course or mold design. And if you are indirectly referencing, especially if you have those large assemblies. Check out our large assembly service or our workshop. And at this point, I'm going to open the floor for questions. I see a few coming in. Pascal, so his question is your presentation going to be available? And yes, this is going to be, well, it is recorded and it will be available on demand for you guys to view at a later time. And I believe we'll be making the PowerPoint available to you folks as well. If I replace the, Ian, I'm going to assume there that your question is referring to 3D Interconnect. And if I replace the file with the same name, it's still going to lose those references. It's got all those internal IDs, and it just, once it reads it in, it kind of recreates those. So I'll still lose everything. Does anybody else have any questions? Yeesh, quiet crowd. Vin is asking, can features be derived from STL files? And they actually can now in SOLIDWORKS. So that's one of the newer enhancements. And that's going into mesh modeling. So if I bring in an STL file, what I can do is essentially extract surfaces from those tessellations or mesh surfaces. And I could also decimate it to make it a little less of an impact performance-wise. And then, yes, I can get features, surfaces, all that great stuff from those STL files. You can also go the other direction and take your imported geometry and convert those into STL or mesh bodies. All right, everyone. Well, doesn't seem to be any other questions. So I hope you enjoyed this webinar and have yourselves a good day.